everybody, welcome back boys and girls. It's your main math man, Shank, coming to you live from Summit Academy. In this video, we are working on still that unit number 5, lesson number 16, still talking about volumes of cones. And so our objective is we'll be able to calculate the value of one dimension of a cone when we are given the volume. So similar to when we calculated the dimension of a cylinder when given the volume, we're going to be doing the same idea with a cone. So the formula is going to be a little bit different because remember the formula for a cone is going to be given as volume of cone is equal to area of the base, which is going to be the same as pi times the radius squared times the height, and the main difference is it's all divided by 3. So let's see how we can apply that to this. So it says number talking in thirds. So it says for each equation decide what value, if any, would make it true. So for this one, we could multiply both sides by 3. So we're trying to use those inverse operations to get that variable by itself. So it's almost like I'm multiplying. So let me move this down a little bit. So 27 equals 1/3 times h. It's almost like I'm multiplying both sides by 3 to get rid of that fraction. And so I could say h equals 3 times 21 is going to be 81. So I'm going to say h equals 81. For the next one, similar idea. I'm going to multiply both sides by 3 to start off. So let me get rid of this. Say multiply both sides. So if I have 27 equals 1/3 r squared, I'm going to multiply both sides by 3 to get rid of that fraction. So now I have 81 equals r squared. And to get rid of that exponent, make sure you're taking the root. And since we have exponent of 2 or power of 2, we're going to take the square root. So you take the square root, and I'm going to just say r equals 9 for this one. Same setup for the third one. What I can actually do is I can cancel out or divide both sides by a pi because it's on both sides, and I can multiply both sides by 3, and so I do a equals 3 times 12, which is 36. So I'm going to say a equals 36 for that one. And for that last one, same first step, divide both sides by pi, and so now I have 12 equals 1/3 b squared, multiply both sides by 3 to get rid of that fraction. And so I can say I have 36 equals b squared, which I can take the square root to get rid of that exponent. And I'm going to say b equals 6 for that one. Moving to the next part, it says the volume of a cone with radius r is given by the formula v equals 1/3 times pi times the radius squared times h. So that's just like the formula I started out with. I said volume of a cone is equal to area of the base, which is pi times r squared, times the height divided by 3. So these are going to be the same exact formula. It says the volume of this cone with height of 3 units and radius r is given by v equals 64 pi cubic units. So it sets it up the equation for us, and it says what is the radius. So we have to be able to find and solve for that radius. So what I'm going to do is this. I'm going to say, all right, let me write this down here so that way it's a little bit bigger. But I have 64 pi equals pi over pi times r squared times 3 over 3. And actually these cancel out because 3 divided by 3 is 1. And I can also divide pi from both sides. So what I have right now is I have 64 equals r squared, which I can just take the square root of both sides. So I'm going to say r equals, let's say, 8 units. Alrighty. Moving on to number 3, it says cones with unknown dimensions. So it says each row of the table has some information about a particular cone. Complete the table with missing dimensions. So again, make sure you're if you're given the radius, we can figure out the diameter because we say d equals 2 times the radius. So we can say, well, 2 times 4 is 8, and 2 times 1/3 is 2/3. Same idea with the radius. If we have radius, we can do radius equals d divided by 2. So for this one, we can do 20 divided by 2 is 10. So you can fill in some parts that you have already. Otherwise, we'd say the area of the base, again, is going to be pi times the radius squared. So we do 4 squared times pi, which is the same as 16 pi. Then if the height is 3, remember when you have the volume of the cone, it's going to be area of the base times the height divided by 3. So it's almost like we're dividing by 3 here to make sure we do it. So we do 3 divided by 3 is 1 times 16 pi, so we're going to say that's going to be 16 pi cubic units. Now if we take this one squared, we have 1/3 squared times pi, which is the same as 1/9 times pi. So if we do that divided by 3, it's going to be equal to 2. So I have 2/9 times pi as our volume for that cone. All right, so now what happens if they give us the area of the base? So if we give us 36 pi, well, I can change that into our radius squared. So I'm going to say, hey, that's the same as 6 squared times pi. So that means our radius is 6, and that means our diameter is 6 times 2, which is 12. So now I can do, all right, I have 36 divided by 3, because I have to divide by 3 here, because that's going to be part of the volume. So 36 divided by 3 is 12, and 12 divided by 4 is 3. So this is going to be 3 pi. Let me actually write that. So let me say 36 divided by 3 is 12 pi over 4, which is the same as 3 pi. And so now let's go in reverse now. Or actually we can do it like this. We can say, all right, if the radius is this, we can say, all right, this is the same as 10 squared times pi, which is the same as 100 pi. And so let's try to find that missing piece. So if we have something times 100 pi divided by 3, we end up with 200 pi. So if what we can do is we can fill in the blank. We can say, well, if this is divided by 100 pi, that's equal to 2. And so what we can do is we can say, well, I need to have something where this number divided by 3 is equal to 2. So we're going to say that our height for this one is going to be 6. Same idea. We can do this divided by 3 to get our missing piece. So we're going to say that's equal to 4. So I have this divided by 4 is equal to 16 pi. So that means this is 16 pi, which is the same as 4 squared times pi. So that means our radius is 4 and our diameter is 8. And then lastly, that one's really easy because if it gives us the volume is 3.14, that means that the radius and the height both have to multiply to just be 1. So we have 3 divided by 3 is 1, and that means the area of the base is going to be 1 because the area of the base is going to be pi, because pi squared times 1 squared times pi is going to be just pi, and we double that radius to get our diameter. So a couple different ways to approach it, and make sure you calculate it carefully through those parts. All right, moving on to number 4, it says popcorn deal. So it says a movie theater offers 2 different types of containers. So it says which container is the better value. So that means we're going to say for better value, we're going to find the volume. We're going to find the volume and divide it by the price. That way you can figure out how much we're actually saving per container. And it says use 3.14 as pi. So anytime you see pi, just make sure you put 3.14. Alrighty. So for the cone, let's do the cone first. So I'm going to say the cone is here. Actually, let me split it. Let me split it like this. We'll say right down the middle. I'll say cone. I'm going to say, all right, well, what do we know? If we look for the radius of the cone, well, we have the diameter is 12, so that means that this radius is 6, and this radius is going to be 4. That means the height of the cone is 19, and the height of the cylinder is 15. So now that we have those labels down, we can have our formulas. So I need to find the area of the base, which is going to be big B equals pi times the radius squared, which is equal to 3.14 times the radius, which is 6 squared. And that's going to be equal to 113.04. Now we can find the volume of this cone, so we're going to say the volume of the cone is going to be big B times h over 3. So I plug in those values. I have 113.04 times our height, which is 19, all over 3. And so this is going to be equal to our volume. So we're going to say our volume is equal to 715.92 centimeters cubed. So this is going to be our volume, but we have to make sure that we divide it by our price. So I take the price, this divided by the $6.75, which is the price. And so I'm going to say that it is, let's say, the volume divided by price is equal to 106.06 with the 2 repeating. So because that's the number we're going to compare to the cylinder. So for the cylinder, we're going to say, all right, same setup, area of the base equals pi times the radius squared, which is going to be 3.14 times 4 squared, because the radius of that cylinder is 4. And that's going to be equal to, let me make that actually a little bit smaller, say equals, and then we said 3.14 times 4 squared. And we're going to say that's equal to 50.24. All right. Then we find the volume of this cylinder. So that's just the area of the base times h. So we're going to say that's going to be 50.24 divided by, times the height, which is 15. And so we're going to say the volume of this cylinder is going to be 753.6 centimeters cubed. And so now we have to take that divided by the price, which is going to be 6.25. And so we're going to say the volume divided by price is equal to 120.576. And so this one is actually going to be the better value. So we'll say the cylinder has the better value. You got to be careful of that, because even though it had a larger volume, it's not always about the volume, it's about, the unit price. So we had to take the volume divided by the price to figure out how much we were actually getting for that container. All right, moving on to the back practice problems. It says the volume of this cylinder is 175 cubic units. What is the volume of a cone that has the same base area and the same height? Well, we can say if we have the same base area and the same height, that means we can say this. We can say the cone's volume is 1/3 of the cylinder's volume. And again, this is only true. I'll try writing that again. Volume. This is only true when this is happening, when it has the same base area and it has the same height area, which is why on that previous one, on the popcorn one, they had a different base and a different height, which means that we're going to have different volume proportions. However, for this one, we can take it 1/3. So all we have to do is I'm going to say the volume of the cone. I'm going to say the volume of the cone is equal to 175 times pi over 3, and I just say cubic units. For number 2, which got cut off, so give me 1 second while I fix that. Okay, so now that's fixed. Now we're good. So we're going to say for number 2, it has a cone has a volume of 12 pi cubic units, and its height is 4 inches. What's the radius? So we're going to be finding this cone. So first I want to draw that cone like so. Put that dot somewhere like that. Connect those edges, something like that. So we're going to say this volume is 12 pi. We know the height, which is going to be h equals 4. However, we don't know the radius because that's what we are solving for. So we're going to say r is what we're solving for. So let's set up our formula first. So I'm going to say I have volume equals area of the base, which is pi times the radius squared, times the height divided by 3. Plug in the values that you have. So we're going to say this is going to be the same as we have 12 pi equals pi times the radius squared times 4. So let me put these in parentheses. So times 4 divided by 3. And so this one is a little weird just because we have to, we have to make sure that we multiply. We're going to do this. I'm going to multiply by the reciprocal. And so that means I'm going to flip this fraction. So instead of 4 over 3, I'm actually going to multiply by 3 over 4, so reciprocal. So the pi's cancel out on both sides, and then what I do is I multiply both sides by 3 over 4. 3 over 4. That way, these cancel out, and I do, on the side here, I can do 3 times 12 divided by 4 is the same as 36 divided by 4, which is the same as 9. So I'm going to say that is equal to 9, which is equal to r squared. Take the square root of both sides, and we're going to say r equals 3 inches. So the radius for this cone is going to be 3 inches. Moving on to number 3, it says a cone has a volume of 3 pi. Again, remember that this is going to be set equal to pi times the radius squared times h over 3. So for each of these, we're just going to have to solve for what the height is. So it gives us r is 1. So we're going to set it up like this. I'm going to say 3 pi equals pi times h over 3. This works out because our radius is 1, so it's almost like we're multiplying by 1 here. So for this one, I'm going to cancel out pi on both sides. Actually, let me write that down. So for each, cancel pi out from both sides. So now we have h over 3 equals 3, so that means I have to divide both sides by 3, or sorry, multiply both sides by 3. And so this is going to give me h equals 9. For the next one, same setup, however my radius is 2 now, so I'm going to say I have 3 pi equals pi times 2 squared times h over 3. So again, the pi's cancel out, and we're going to multiply both sides by 3. And multiply both sides by 3 to get rid of that denominator. And so this gives us 9 equals 4h, which I can divide both sides by 4 to get rid of my coefficient. So I'm going to say that this is going to be h equals 9 over 4. And even if it's a fraction, that's okay. We can still leave it be. For part C, our radius is now 5. So we're going to say, okay, we have 3 pi equals pi times 5 squared times h divided by 3. Same steps, divide both sides by pi, and I'm going to multiply both sides by 3. So same first step each time. Make sure you're taking it one part at a time. So this is going to give me 9 equals 25h. And for this one, all I have to do is divide both sides by 25 to get h by itself. So for this one, we say h equals 9 over 25. For part D, what I can actually do is I can kind of skip some steps. I'm going to say, well, I'm going to have, again, 1 squared is the same as 1 over 4. So what I can do is I can say, well, I can have 9 equals 1 over 4 times h. That way, I can save some time. I can go to the next one. I can say, all right, well, this means that h is going to be equal to 36. And now when the radius is r, what is it going to be? Well, what we can do is we can write it like this. It's going to be, for this situation, we're going to say that h is going to be equal to 9 divided by r squared. So that's just saying in general, if your volume of a cone is 3 times pi, what is going to be the height for each of those depending on what the radius is. So we're just saying that the height is going to be equal to 9 divided by the radius squared. And for the last one, it says a room is 15 feet tall. An architect wants to include a window that is 6 feet tall. The distance between the floor and the bottom of the window is b feet. And it says the distance between the ceiling and the top of the window is a feet. It says this relationship can be described by the equation a equals 15 minus b plus 6. So what do you guys think? Which is going to be the independent variable based on this given situation? So again, independent variable is always going to be that x value if you were looking at a graph. So we're going to say this is going to be just b. So independent, let me say that. Let me say independent variable is b. And then for the next part, it says if the architect wants b to be 3, what does this mean? And it says what value of a would work with the given value of b. So let's find out. So we're plugging 3 into our function. So instead of b, we now have 3. So I'm going to say a equals, write that again, a equals 15 minus parentheses 3 plus 6. So this is going to be equal to 15 minus 9, which is equal to 6. So when b is 3, a equals 6. And then for part C, it says customer wants the window to have 5 feet of space above it. Is the customer describing A or B? And what is the value of the other variable? So they're actually describing A for this one. And so what we do is we can set it up and we'll say this. We're going to say 5 equals 15 minus b plus 6, which I can rewrite this to be, actually let me let me use my inverse operations. I'm going to subtract 15 from both sides. So on the left side, I have 5 minus 15 is negative 10. And on the right side, I just have negative b, that should be a 6, b minus 6. I'm going to actually keep that in parentheses. So let me say, keep that in parentheses. So let's say negative and then b plus 6. Now I can divide both sides by a negative 1 to get rid of that negative coefficient. So now I have that this is going to be, let me move it up here. So negative 10 divided by negative 1 is positive 10. And so now I have positive 10 equals b plus 6. Subtracts both sides by 6. And we get our answer, so we're going to say b equals 4. So make sure you can set up those equations and solve for the unknown variable. Lastly, for the exit ticket, it says Noah and Lynn are making paper cones to hold popcorn to hand out at a parent math night. They want the cones to hold 9 pi cubic inches of popcorn. What are two different possible values for the height h and radius r for the cone? So yeah, so you are given the volume, so that's going to be the volume. So you need to come up with, well, what is going to be the possible heights h and r. So what I would suggest you do is write formula and try values. Let's try writing that again. Values of h and r. So try that out. Be sure to ask questions as they come up. And as always, super slam that subscribe button.